Hello, and welcome to today's webinar on what's new in CADfix PPS 3. This webinar will focus on the newest release of model simplification and automation using CADfix PPS. My name is Kristen Gray, Global Marketing Manager for ITI. It looks like most people have joined, so we'll get started. I'd like to start with a few housekeeping items. As I mentioned before, we will keep everyone muted to avoid any echoes during the presentation. If you have any questions, please feel free to drop those in the questions window or raise your hand if you need help. Today's presentation is being recorded, and we will send out a link for you to re-watch or share with colleagues after the webinar. Today's presentation is 45 minutes, and we will have time for a Q&A session at the end. If you have any questions during the presentation, please feel free to send them in the questions window, and we'll answer them in the order they came in. Thank you for joining us today for our What's New in CADfix PPS 3 webinar. For today's presentation, I would like to introduce Elliot Samuels, CADfix PPS Application Engineer. Elliot is an application engineer with ITI based in Cambridge in the United Kingdom. Elliot has experience using CADfix PPS and a master's in mechanical engineering from the University of Bristol, England. Please join me in welcoming Elliot Samuels. Elliot, I'll turn things over to you.
Thank you, Kristen. I'm Elliot, and I'll be presenting this webinar today, where we'll be looking at CADfix PPS 3, the newest release of our MCAD model simplification solution. So let's jump straight in and get started with a slide to outline the scope of this webinar. We'll start today with a brief overview of the key functionality and capabilities of CADfix PPS and the value gained through employing an MCAD simplification solution in your processes. Following this, we'll move on to some discussions surrounding the new release of CADfix PPS, CADfix PPS 3, focusing on enhancements to automatic and batch simplification, some new functionality for interactive simplification, an updated user interface, and finally, import and export interface updates. All of this information and discussion will be interspersed with some examples and case studies, as well as some demonstrations of the new functionality. And then after all that, we'll have just a couple of summary slides to finish off. So a brief overview of CADfix PPS. What is CADfix PPS? It's a CAD model simplification solution employed to significantly reduce MCAD file sizes, simplification carried out interactively or fully automatically, with support for batch processing of models through the interface or at the command line. So model simplification to reduce file sizes fully automatically with the opportunity to batch process models. And how does it achieve this simplification? Well, it has a number of simplification tools to remove unwanted small bodies, such as nuts, bolts, washers, and small brackets. Remove CAD features, so holes, protrusions, fillets, logos, embossed text, and engraved text, and things like that. Automatically identify and remove internal parts, and simplification of complex parts to sort of more basic representations, more basic shapes. And when we employ all of these tools together, the data reduction in a CAD model can become significant. So here's just a good example of this. We have an original model here. It's a 40 megabyte DWG file, and this has been simplified to produce a 1 megabyte DWG file. And the model has retained its key features for space management and clash detection, but our simplified 1 megabyte file is more manageable in downstream systems and is also much easier to distribute than the original 40 megabyte file. And this order of magnitude of data reduction is significant. When we look at simplifying multiple assemblies that make up a plant layout or manufacturing plant layout, factory layout, or a marine engineering system, whatever it is, the cumulative data saving can be multiple gigabytes. And this significantly reduces the time and effort required during the implementation of your CAD into downstream systems. So that's just a very brief, high-level overview of CADfix PPS. We'll now move on to the focus of today, which is the new release, and explore some of the new and improved features that CADfix PPS 3 has to offer. So we'll start with automation and batch. A key focus throughout the development of CADfix PPS 3 has been on improving the performance of the automatic model simplification process. PPS 3 provides a more robust, efficient, and consistent model simplification whilst maintaining this essential balance between processing time, data reduction, and model simplification results. And this has been managed through the implementation of new functionality, enhancements to legacy features and functions, and greater simplification process intelligence, all of which are fully integrated into the automatic model simplification process, meaning no major change to pre-existing user workflows when processing via the automatic simplification wizard or in batch. So let's take a closer look at some of these key functions and features, both new and enhanced for CADfix PPS 3. The first of which is the retainable keep list. So in CADfix PPS 3, users now have the ability to save, combine, and recall keep lists. These keep lists can be exploited not only through the interface, but also in the batch processing of models. Keep lists are defined using selection rules, so attributes such as topological shape, approximate size, approximate centroid location, as well as properties like labels, colors, and layers. And we can use different combinations of these save selection rules, and they can be employed for different use cases. And I'll discuss this in more detail in the examples we're about to see. So let's have a look at the new keep list functionality and a few of its use cases. I've pre-recorded this example just so we can skip through any automatic processing times, but I'll highlight these times as we go through. So in my folder here, we have 4 separate step files. 2 of these files, the fan and the motor, are very small, only a few hundred kilobytes. They're likely singular parts or components, and we expect that they're going to occur in some of our larger assemblies. We have our cabinet, which is around 16 meg, and our spools and gearbox file, which is around 83 megabytes. So we'll open up one of these small components. We'll start with the fan, and we'll form a retrievable keep list. So if we go into our keep list section, which is just in our auto simplification section in the top left, to select the component, we go to this keep list area and we can just select the body off screen. And we can see that it's populated this keep list and we have a total of 1 body as we would expect. And then to save our selection rules, we go and hit the save icon. And the save selection rules will pop up on screen. Now we can select any combination of these attributes. So we have shape, size, and location, as well as our label, color, and layer, our non-physical properties. And so let's say for this fan, we want to keep the instance of the fan in an assembly, even in the event that the original CAD design of the fan changes slightly. The shape is no longer the same, but the approximate size will likely be, as will the position of the component in the assembly. So for this use case of an updated version of a component, we'll use size and location. We can hit the test button and we can see that it's refound that. And then we can save this. We can save this as a new .csr file and we'll call it fan.csr. So we'll now do this with the second component, the motor. And this time we'll look at a different use case. So again, we're going to our keep list, select our motor and hit the save. This time we're going to base the selection on shape and size. So this combination will find all of the motors that are identical to this one in any position in any model. It won't find updated instances of the motor as the topological shape has to be the same. And finally, let's take a look at our cabinet. It's a slightly larger model, so we'll expect maybe some repeat components here. So this time we're going to look at the table's feet, a component that will likely be repeated across many models and possibly with variations in size, slight shape or color. And we're going to use this as an opportunity to take a look at one of the non-physical attributes that can be used in our selection rules. So open up the model tree on the left-hand side and select one of these components. We'll see that they all have the same assigned label feet. So we can utilize this label attribute in our selection rules. We want to retain all of the table legs of this approximate size, regardless of the shape or location, as they'll appear in many places around our model. So when we test this rule, we'll see that we'll correctly identify all 4 table legs, as they all have the same label and are roughly the same size. So as before, let's save this .csr file as cabinet, and we'll move on to our final and largest model. So we have our larger model here. It's 83 megabytes roughly. So identifying components for adding to a keep list becomes more difficult as models become larger. So by accessing our key parts at component level, this saves us time of having to import and interrogate larger models to find these components. Say we have an assembly in SolidWorks, or we've got all our SolidWorks parts or our IPT files from Inventor. We can just access those small files, import them, save a keep list, and then we can use those in batch later on. So we've opened up our model. It took around a minute to import, and we'll load our keep lists. And we'll start with our small components, which are our fan and our motor. So we go to our keep list section, and we go to this open file here. And we'll start with our fan. And as you can see, we've found one fan, potentially an updated version of the fan that we looked at before, potentially the same, but this fan has the same location relative to the origin and the same approximate size. And we've also found one motor, and we know that this motor will be identical to the one that we looked at previously. In this model, we have a few more table legs than before. And as you can see here, that they're all labeled as feet, as is the convention with the set of models that we're processing. And if we highlight them in the tree, we can see that we have 2 smaller legs and 4 slightly larger ones. So before, we saved our selection rules based on size and label. So we'd expect to find all of one size of table legs, and we have here. So if we'd saved it with just label, we would have found all 6. If we'd saved it with maybe label and shape, it may have found them, depending on whether those big table legs are just a scaled up version of the small ones. So we've loaded our rules, and we can see that they've selected the components we would expect them to. And now all of these components are exempt from any simplification. So we'll simplify this model just using the standard auto simplify level 2 settings. And we'll skip the processing time here. And I'll highlight how long it takes after it's done. So as you can see, it's taken 227 seconds, so just under 4 minutes. We've removed 91.3% of the faces in the model, as you can see in the top right, which will be approximately around 95% of the total data of that 84 megabyte file. And importantly, we've retained all the detail on these components that we identified as important and used in our keep lists. So this is great for processing CAD on a model by model basis through the interface. But what can we do if we want to process a whole suite of models and retain a set of key components across that whole set? Being able to save and load keep lists means that this functionality can now be exploited when processing your CAD data in batch. And in order to do this, we need to form the keep lists as we did before and concatenate them to form a single .csr file. Then we need to include this keep list file in our configuration file so that we can use it for batch processing. So we'll open up all of these files in a text editor. and we can simply combine the contents of the individual keep lists. So this is our fan keep list, and we'll take this and we'll copy it, and let's put it into our cabinet keep list. And then we'll do the same for the motor. And we'll save this and go into our configuration file. And if we go down to the transform section of our configuration file, which just contains all of the settings and tools and settings that we want to use to process our models in batch. At the top of the transform section, there's this keep list section, and we just have to put the path to our keep list file, our .csr file in here. And then from here, we can continue batch processing our CAD data as normal as with the previous version of CADfix. So that's the first piece of new functionality that we'll cover today. There's a few more bits of functionality regarding the automatic simplification. And the next area we'll look at is the improved processing of pipe runs. So CADfix PPS can now identify the small bodies that form sections of pipe runs. Pipe fittings, small valves, and elbows are now recognized by CADfix and will no longer be identified and subsequently deleted as small bodies during the automatic simplification process. This prevents disconnected or broken pipe runs, giving more appropriate results for downstream clash detection or space management. We've got a couple of examples here. So the first one, the one on the left, just shows the preservation of a few pipe fittings. And the second is on the right-hand side is a case where we have retained a significant section of the pipe run that is comprised of 9 consecutive small bodies. Another area in which CADfix PPS utilizes greater intelligence is in the preservation of conical end caps. And this is in addition to the improved identification and handling of domed end caps. The automatic identification and extraction of end caps ensures a superior simplified result with a more accurate volume retention. Again, making results more suitable downstream for space management, clash detection, and visualization. Again, take this example, it's of a large dust filtration system. It's quite clear that the result is improved, more closely aligning with our original model's volume. And the third key area in which CADfix PPS 3 demonstrates greater intelligence is in the selection of candidates for simplification to primitive solid representations. The identification of gears and sprockets for cylindrical simplification is a prime example where we can now remove large amounts of surface detail whilst maintaining the general volume or outer envelope, as you can see here. So all of those three things are our pipe runs, our end caps, and our primitive candidate selection are all things which are fully integrated into the automatic process. They don't require anything from the user, and it just means that you'll get a more consistent and a much greater simplification result than in the previous version of CADfix. And as well as improvements to our automatic simplification process, we have added 2 new interactive simplification tools. These tools provide greater control over the simplification of complex components to ensure the desired balance of simplification and retention of detail can always be achieved. So let's take a look at our new manual tools, the first of which is an extrude face tool. The extrude face tool is designed to allow greater control over the simplification of complex components, where successful simplification is subjective. Using the existing geometry of a body and selecting specific faces for extruding allows complex components to be rapidly transformed into more rudimentary representation, whilst retaining key features of the part, maintaining the aesthetic integrity and the volume of the original component. As you can see on the right here, I've simplified this component to 3 varying levels. The result on the left might be the most appropriate if I need, say, a lightweight model for a space management application, and maybe on the right for IP protection, where we're looking to remove IP, maybe just the blades of the fan or the fins, cooling fins at the back, whilst maintaining as much of the aesthetic as possible. Either way, the extrude face tool offers greater flexibility to the user when simplifying these complex parts. So let's have a look at the new extrude tool being used on a few complex components. We have a model here, and it contains a lot of complex bodies. We want to simplify them, maintain a close representation to the original solid volume, and keep key features such as regions where components connect and interact with each other. Now, I can turn these complex components into bounding boxes, but in some circumstances, this is too much of a simplification and a gross overestimation of the original volume. We also lose that detail surrounding our connection points and the aesthetic integrity of those components. So instead, we're going to use our new extrude face tool. To form our swept volumes, we need to select a face to extrude and a point on that body to extrude the face to. We also have options to remove holes in the swept volume and also to replace the original body during the extrusion. So let's isolate some of these complex components on the screen and hide the rest of the model. And I'll go through and I'll simplify 3 or 4 of these components one by one. So let's start with this small valve, and we'll show a basic extrusion. So if I sweep this hexagonal face on the end, and we'll leave our tools on, I'll remove holes and I'll replace original bodies on. Then, as you'd expect, this is what we're left with. Clearly, this doesn't represent the original body very well, so we need to turn off the replace original body until we've formed all of our extrusions. So this component looks like it has 3 or 4 main sections, so we'll create extrusions for each and then replace the original during the last extrusion. And this has clearly given us a much better simplified representation of the original component than a bounding box. We've retained some details around where the body connects with other bodies and also the top handle. So let's do this with a slightly larger component now. We can still make out a few obvious sections here that would better represent this component than a single box would. The top section, we've got a cylindrical body, a flange where the component may be bolted down, and we've got a connection point at the bottom and also at the top on the side. Here we'll also make use of the loop selection tool to select a circular face to be extruded, where this face is not readily available on screen for selection. And again, we're maintaining the shape of our points of connection between this component and the components it interacts with, where previously this detail was consumed by the bounding box. Here we're removing holes, removing the holes in these connection points, but if we wanted to, we could turn off that remove holes tool and retain that hole. We can also use the loop selection to select this hexagonal face to represent this large protrusion on the top of the component. And we'll replace the original body. And again, we're left with a much simpler representation than we started with, but we haven't grossly oversimplified. Again, here we have a component with a few more complex features, but again, this tool is very intuitive and can be used to rapidly form much more appropriate simplified representations than a bounding box. We're simply tracing over the pre-existing geometry. It doesn't require too much thought. You don't have to create any geometry in the model. You're just using what's already there. And as we simplify this component, we're removing a large number of faces and greatly reducing the file size of the model. If we look at the face count reduction in the top right of the screen before and after we remove the original body this time, we'll see just how significant the contribution to file size a few complex components can make. So this is our last extrusion, and we'll replace the original body. And now we can see, after simplifying just 3 complex bodies in this model, we've removed 12.4% of the faces in the model, and a similar amount of the total data. And so when we use this tool in conjunction with our other simplification tools, we can achieve a very high data reduction with consistency of our simplification results. This tool also provides a high level of control over the outcome for the simplification, which for IP protection, we can remove areas of key detail while still closely matching the original component. Here we may want to cover our fan blades and our cooling fins, whilst maintaining the points of connection in the feet and at the top. So we'll just do our last few extrusions. And now we've simplified a few of these bodies, what we'll do is we'll unhide the rest of the model and see how these components fit within their assembly. Our components are easily identifiable. Their points of connection have been retained, and their volumes more closely align with the state pre-simplification, making them well suited for space management, clash detection, and visualization. The second new manual tool that we've added is a new facet decimation tool. So the facet decimation tool has been added for the reduction of triangle count in faceted models. Faceted parts can be selected and decimated with user control over the decimation tolerance. This gives the user governance over where detail is removed from the model, allowing important components to retain their detail while still providing significant file size reduction. On the right, we have an example of this facet decimation on a gear. We can still clearly make out the component to be a gear post-decimation. We've retained the aesthetic of the component whilst reducing the total number of facets by 71.4%. And this is a significant reduction. Decimation can be applied to selections of faceted components. We're processing the model interactively by making selections, but can also be applied sort of blanket across a whole model through the automatic simplification wizard. And there are 2 new manual tools. So the next area we'll take a look at is the import and export. These 3 bullet points are just a few of the key changes, a few of the highlights, but we'll have a look in more detail over the next few slides. The main points are we've updated our interface support for our imports and exports. We have a new auto cleanup process of model geometry during the import stage, which increases the efficiency and effectiveness of the simplification tools. And finally, we also now have the ability to merge files. So we'll start with the imports. The new release sees updated import support for proprietary CAD formats, as well as our neutral DWG, Parasolid, and ACIS, as seen in this list. There are also some improvements to the CADfix import process too. As I mentioned before, the auto geometry cleanup or minimal repair process makes tool usage more effective and efficient. Closed surfaces are split during import to improve model shading. The import of transparency attributes is now fully supported. There is a new option to promote face colors to bodies, and this display option can be switched back and forth between associated body and face color during the processing interactively. And we also have a faster Creo import. And similarly, our export support has also been updated to include the latest versions. And this includes a new addition to the exports with support for CATIA v5 as geometry or as a faceted representation. And again, with the import, CADfix PPS 3 now supports the export of transparency attributes. So CADfix PPS 3, as I mentioned in a couple of slides before, supports the merging of multiple files into one session. So this can be done during the import. We can merge files into an open session, and we can also drag and drop additional models into the workspace. And this enables us to reuse pre-simplified parts to avoid repeated work. Merging can be useful for replacing individual complex components or for combining entire sub-assemblies. And we'll take a brief look at the new merge functionality. Again, I pre-recorded this example just so we can skip through the import time. It's around a minute, but I'll highlight that as the video runs. So here we've got some of the same components that we saw previously in the keep list section. However, this time we've already simplified our cabinet, our fan, and our motor. We're going to open up this large assembly and shade the model. Here I'm just going to show how we can drag and drop some simplified versions of our CAD directly from our file browser, but files can also be merged during import as long as all the files are of the same type, so all step or all DWG, or files can be merged into an open session. So we'll start with our fan and our motor. So if we go to our fan and our motor in this model, just underneath this table here. So I know I've spent some time forming a simplified fan using the extrude tool. And so instead of processing this component again, I just want to reuse the one that I've already simplified. So if I go into my file browser with all my simplified files and find our simplified fan, I can just drag and drop this into the session. And we can delete our old fan. And again, we can do this for our motor. I'll delete the motor first this time, and then drag and drop our simplified motor from the file browser. And in the case of single components, where the simplification might not take a very long time, it might be easier to just re-simplify the model. But maybe you have a file containing many components or a few complex components where you've invested some time forming extrusions to get the best possible simplified result. Or maybe you just simplified on a sub-assembly basis and you want to merge all those sub-assemblies into one file. In this situation, merging files can save considerable time and rework. So that's just a brief look at the merge functionality. The next section we'll talk about is the user interface and display. So CADfix PPS 3 has a new look to its user interface with a new layout and cleaner style. It's been designed to reduce mouse movement and improve readability. We've also added a new progress status tool, which provides useful metrics for the percentage reduction of bodies, faces, and facets throughout the simplification process. I've actually highlighted it a few times in some of those demos. The reduction in face count gives insight into how much data is being removed from a model as we perform the simplification, showing how effective individual tools have been with regards to total data reduction. The face count reduction is typically a slight underestimate of the total file size reduction, assuming that the file type read in and exported are the same. And finally, for this section, CADfix PPS 3 is faster to display shaded images than in previous versions. And finally, last but not least, CADfix PPS 3 has a new HTML help manual accessible through the user interface. The manual is a comprehensive source of information regarding the full scope of CADfix PPS's functionality, from high-level detail on tool usage to more intricate details such as shortcut keys. It's intended to provide instant support to the user and advance their understanding of best practices when using CADfix PPS 3. Together with updated tutorial materials, CADfix PPS 3 comes with all the documentation needed to quickly become an expert in MCAD model simplification and data reduction. So this is just a summary of everything that we've covered today. We've updated our import and export CAD version support with an additional new CATIA v5 export. We now also support the import and export of transparency attributes. We've improved our automatic simplification process to provide a more robust, efficient, and consistent, fully automated MCAD model simplification solution. We've added the new retainable keep list functionality and made this exploitable in batch model processing. We've added 2 new manual tools to provide greater control over the simplification of complex parts and also reduce poly count in faceted models through decimation. We have a new user interface designed for greater usability and readability with the addition of a simplification progress tool for some user insight. And we've added our new HTML help manual that gives the user a readily available and comprehensive source of information and support. So CADfix PPS solves MCAD model size problems faced by process plant, marine and power engineers. It reduces engineering design labor associated with model simplification and integration downstream by up to 80%, increasing profitability and saving labor costs, avoiding penalties for project delays, and allowing more time to be spent on value-adding work. So days of non-productive geometry handling, increase efficiency, decrease time to market, and get to commissioning faster by employing automated CAD model simplification processes. I hope that this has given some insight into the capabilities of CADfix PPS 3 and all its new functions and features, and also just all the improvements to legacy functions, as well as what can be achieved in terms of CAD model simplification. If you think that PPS could be of value in your processes, please register for a free evaluation by following that link. Getting hands-on with the software and processing some of your own data is the best way to see how CADfix PPS can work in your processes. That's it from me for today. Thank you for your time. Thank you for joining, and I will pass you back to Kristen.
Thanks, Elliot. I appreciate it. Hopefully that was useful for you guys. At this time, we will hold a Q&A session. So if you have any questions, feel free to drop those in the questions window, and we'll answer them as they come in. So first up, we do have a few questions here. How do we ensure that no data is lost in the simplified models? Is there any control over how much data is restored?
I'm sorry, so in terms of what data is lost, well, you keep the original model, so you're never going to lose anything permanently. In terms of control over what's being simplified, as we just covered there, we have that the retainable keep list. But the changes to the model aren't permanent. You have your model and you can process it. You can select which tools you want to use, or you can process interactively. And there is quite a lot of control over the simplification process. And then you can save that out at the end as a new model.
Okay, great. We have a few more questions here. Is there a limit on how many items can be kept in a keep list?
No, I don't believe so. No, I think you can keep as many as you'd like.
Okay, perfect. And the next question, what is the licensing structure for CADfix PPS? Is it a network license or a node lock?
We offer both. We're quite flexible with licensing, and we can offer network licenses and node lock licenses. And that's if you get in touch and have a trial and get in touch with one of the sales guys, they'll take you through the licensing in more detail. But we do offer both.
Okay, awesome. We have time for a few more questions. Feel free to drop them in the questions window. The next one is, during the extrude phase step, does the part get split up?
So if you form multiple extrusions to represent one part, then that will be multiple bodies, but it will be held in the assembly structure under that under the one component. But it will be multiple solids. But you can also use the extrude face just to form one representative solid if you chose to.
Awesome. Thanks, Elliot. How much time on average can be saved by using CADfix PPS simplification tools?
A lot. If you think about the level of data reduction that you get, which is often in the 85–90%, and can be necessary downstream in plant design systems, they can't handle the amount of data in these large models. To process well, it varies depending on model, but you can process large amounts of data, say hundreds of megabytes in 20 minutes, half an hour, which if you were going to do the alternative by hand, going in and creating shapes and deleting things manually, that would take a long time. But yeah, you can process large amounts of data very quickly and set these things up to run in batch via the command line overnight, so that you're not really it doesn't require human interaction, it doesn't require manual work.
Great. It looks like that's all the time we have for questions right now. If you have any other questions, feel free to keep sending them in and we will answer them later on today. Thank you all for joining us for our What's New in CADfix PPS 3 webinar. Concluding the webinar, we will be sending out an email with a link for you to rewatch this. If you have any questions, feel free to contact us at info@iti-global.com and we'll put you in touch with the right product expert. Thank you, Elliot, for your time today. Thank you all for attending, and we look forward to connecting with you shortly. Have a great day.
Thank you. Bye.